Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ammar bin Redha. My mention number is 1756 and 48. Okay, today I will explain about one-step binomial model for stochastic and option price. So now for problem 2, okay, the stock price is currently RM50 and the end of 6 months the stock price will be either RM45 or RM55. The risk-free rate of interest is 10% per annum with continuous compounding. Calculate the price of a 6-month European put option with strike price of RM50. Okay, first of all, what we want to calculate actually is F, denoted by F, the put option price. Okay, and F, the formula is 1 minus P star times the option price and the whole thing divided by e to the power of r p. Okay, and then before that, let us see how many information given. Okay, given the stock price is currently means as the denoted for the stock price, as not currently is RM50. At the end of 6 months, that means T per annum with continuous compounding. That means we have to divide it into 12 months per year, and we just reverse 0.5, and others is okay. The strike price is RM50, which is same to the stock price, which is denoted by K, which is RM50. Okay, that's the information given, and this is the formula. For that, we miss what the formula for P prime. Then we miss the P prime formula or P star. It's given by e to the power of r t minus d, the whole thing divided by u minus t. Okay, before and forget, okay, we miss something. The risk-free rate of interest 10%, which is r equals to 10%, or converted into decimal 0.10. Okay, this is the formula, and this is the information given. So we substitute all the information given into the formula. Okay, we don't have space for that. Okay, now before we find the put option price, P star. Okay, where's P star? Before I proceed, P star is stand for risk neutral probability, which is that e to the power of r is 0.10 times with t, which is 0.5, compounded monthly, and minus by d. For d, okay, we we have now, currently we have 50. Next is either going upward for 55 or downward for 45. Okay. For this one, for upward, you the 55 divided the currently, which is 50. And then we get 1.1, and then for the D, we miss D. So D is equals to 45 divided the stock price, which is 50, and then we get 0.9. We substitute into the formula. The D is 0.9 and divided by 1.1 minus 0.9. Finally, we get for P star 0.7564. Okay, we near to the end for the question. For the start price, which is F, we plug in the information to the formula 0.7564 times with option price. We ignore the negative part, which is 55 minus 50, we get 5. 45 minus 50, we get negative. We ignore the negative and we times with the option price, which is 5. And the whole thing divided by e to the power of r 0.10 and t 0.5. Lastly, we get 1.16. Okay, because of mentioned by price, then the final answer is RM 1.16. Okay, I think we have solved the question for problem 2. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. My name is Aliff bin Zaman. Aliff bin Zaman. Metric number 173173. Today I will present, or I will teach you about the two-step binomial model. Two-step binomial model was divided by two parts, which is European call option and European put option. So what is the difference between European call option and European put option? First, I will explain about what is European call option. European call option is when our stroke price minus strike price, we get the positive value. But for the put option, when strike price minus stroke price, we got positive. So for more understanding, we go to the question here. Question here asks us currently a stock price is 50. A stock price is 50, which is our S0 is 50, which is S0 is denoted for the stock price. It is expected that the stock price will go up by 6% and down by 5%. So here we need to draw the diagram as is like this. For the stock price here 50, the question wants us go up by 6%, which is our up is 53 and our when go down is 47 ringgit and 50 cent. So we noted as A. It is A, not A, not B, and not C. So next is over each of the next 2-3 months. When we hear next 2, because this is from 6 for 6 months, and next 2-3 months, automatically we use two-step binomial model. Suppose the risk-free rate is 5%. Risk-free rate is our R, which is 5%, or we can write this as 0.05 per annum with continuous compounding. This question was divided into 2 parts, for the call option and put option. For the question A, the strike price, which is K, was given Rm 51, and this is A for the European, call option, which is K equal to 51, and for the question B, which is European put option, and the strike price also given, which is 51 ringgit. So because this is two-step binomial model, this is just for the one-step binomial model. So for the two-step, we need to expand the diagram to 2 parts, which is this and this. So because the magnitude of the up jump is 6% and down is 5%, so for 53 and this 6%, we got 56.18, and this is 50, 55, and go down 5%, which is 45, 30. So next, we already have the strike price, which is 51. Our U is 53 divided by 50 equal to 1.06. Our D 47 by 4 over 50 equal to 0.95. This is the information that we get from the equation. So the call option, we want to calculate the call option. We have 2 ways to calculate the call option. First, directly, which is first direct, which is F equal to exponent negative 2RT T square FUU plus 2P plus P plus square F dB. This is the direct way to find the call option. To find this, we need the information. Like we have already R, T. We still don't have the value of T. So from the question says next 6 months. So our T is equal equal to 6 divided by 12 because per annum. But this is two binomial model, two-step binomial model. We need to divide by 2, which is t. Our t is equal to 0.25. We already get RT. P, we still don't have the value of P. Our P is equal to exponent RT minus T over U minus T. Our P is equal to, we already have RT, D, U and D. We got P 0.5689. This is P. So for the RT and P, we already have the value. Next, FUU, FUD, and FDD. FUD got equal to our stroke price, because this is for A is call option. For A is call option. Our stroke price ST, our ST is our stroke price is 56 minus 1 8 minus 51. We got 5.18. So for this is FUU. For FUD we got 0 and FDD also 0. So we already have all the information. So we plug in into the equation relative to R. We already have R, which is 0.05. Our T 0.25. Next is our P. Our P there 0.5689. 0.5689. FUU 5.1 plus, because of the FUD and FDD is equal to 0, we got plus 0 plus 0. So our F is 1.634. This is the direct way. So for the, we have another way, which is the backward process. First, so I erase the direct way. Still for the question A, European call option, which is first we find the price of the option at not B. So our F is equal to, the formula is little bit different from the direct formula. PFUU plus 1 minus P FUD. So our F, we just plug in into the formula is 0.05. Our R, our T 0.25. Our P 0.5689. FUU, our FUU 5.8 plus 1 minus 0.5689. FUD 0. So we got for the F at B, which is FU at B, so 2.0 So next, we need to find this is price of the option at node B. Next is price of the option at node C. Same way, same formula. We just plug in into this formula, also this formula, which is 0.05, 0.25. Because of our FUU and FUD for the node C is different, which is this FUD is equal to 0, FDD equal to 0. To find this, to find at node C, we use this. So because of that, automatically there is 0 plus 0 and F is 0. So for the last is we find the price of the option at node A, which is this, or equal to our call option. Use same formula, just plug it into this, which is FU and FD, exponent into 0.05, 0.25, P, our P is 0.5689, and our FUU become this, because we already get the FU here. FU here is 2.9103. Our FD here is equal to 0. Because of that, our FUU become 2.9103, and here automatically become 0 because multiplied by 0. F is equal to 1.64, which is same as the direct way to find the price of the option. Next is let's move to question B. For the question B, same way, we already got the information here. We just, the difference is P, we want to find the put, European put option, little bit different from our, to find FUU. We already have K, we already have UD, R, P, just plug into the formula. This is the direct way. The direct way is F equal to exponent negative 2RT P square FUU plus 2P 1 minus P FUD plus 1 minus P FDD. So for the put option, the difference is our FUU, FUD, and FDD. So we will find the new FUU, new FUD, and new FDD for the put option. For the put option, our FUU is 51 minus 56.18. We got 0 because we just take the positive value, but this is the negative value. For the FUD, here we get 51 minus 3.35 got 0.65 and FDD 51 minus 45.13, we got 5.87. This is our new FUU, FUD and FDD to differentiate between put option and call option. So we just put into the formula, which is F equal to exponent -2, our R is 0.05, our T 0.05, our P 0.5689 square, our FUU is 0, automatically become 0 to 0.1 minus 0.5689 times our FUD is 0.65 plus 1 minus 0.5689 square. FDD is 5.87. So this is the price or the put option price in the direct way, which is we got 138. So this is a direct way. Let me move to the another way, which is the backward process, which is a little bit different from the formula. We calculate note by note price of the option at note B. First, we calculate the price of the option. Okay, for the put option, to find the put option backward process, which is our F is equal to exponent negative RT P FUU plus 1 minus P FUD. This is because we want to find the price of the option at node B, this FUU and FUD. Our F just into the question, R is equal to 0.05, T 0.5, or P is 0.5689. Our FUU here is 0. Our FUU is 0 plus 1 minus 0.5689. Our FUD is 0.65. Punch letter and get 0.2767. This is price of the option at node B. So we go to the price option at node C. Same like for option. Use the same formula, but the difference is FUU and FUD. For the node C, we use RT P FUD plus 1 minus P FDD. Why we use FUD and FDD? Because we want to find the price option here, which is node C. We use FUD and FDD. So our F become 0.05, 0.25 times our P 0.5689. Our FUD here is 0.05. 5 plus 1 minus 0.5, 6, 8, 9. Our FTD is 5, 8, 7. So our F or our price option at node C, we got 2.898643. So we got the price and then node B and node C. So the last step is we want to find the price option and then node A, which is our put option, which is price option at node A. Use F equal to RT P FU, which is this is our FU and this is our FD. Q plus 1 minus P FD. So just put into the formula 0 to 5 B 0.5 6 8 9. Our FU is this 0.27667 plus 1 minus 0.5 689. Our FD is 2.86. So punch your calculator and you get 138, which is same as the direct way to find the price option. So that's all the explanation for the two-step binomial model for me. Thank you.
Okay, Assalamualaikum and very good afternoon. Okay, I'm Redha. I will explain to you about the problem 5, which is it is involved for stochastic process, lemma, ethos lemma, and linear process. So for the problem number 5, the question wants to find the process by the bond price. Okay, so the bond price, which variability in terms of t, is equals to e negative x t capital T minus t. So we must use the ethos lemma, which is given from the question. dx is equals to a x naught minus x minus sx dw. Okay, this is a stochastic differential equation that a s and a s is equals to constant. dw is equals to linear process, and then x is a continuous maturity of the 0 point. So for this, I will write this stochastic differential equation. So to solve this problem, we must make this bond price become the differential by ethos lemma, which is we use dB is equals to delta B over delta x, delta B equal to x, a x naught minus x plus dx delta B over delta T, capital T, sorry, capital T, plus 1 over 2 delta square B over delta x square x square B bond dt plus sx delta B over delta T delta x B dz. Okay, for base from the stochastic differential equation, we can make bond price by that formula, which is this is this is the winner process. So in this process, we must find it is have a require of dp over dx, delta b over delta t, and then second derivative of delta b delta x. So to find delta b over delta x, so the first, sorry, I will show the equation. Okay, is dx t minus t, and then we differentiate. We have derivative b in terms of x. We can find t is t minus t small t exponent x t minus t, and then secondly we find the derivative of b in terms of t. So it will become negative x exponent e negative x t minus t. And then the third one, lastly, for the second derivative of b in terms of x, it will show that we can get t capital T minus t square e negative x t minus t capital T minus t. Okay, from this differential derivative, we can substitute in this formula, in this process. So it will become dB is equals to B over T, sorry, negative T capital minus T A x not minus x minus x plus T minus T square over 2 x square dt minus s x t minus t dz. Okay, so the derivative of bond price. Okay, this is the process, and from this process we can find that A S is a constant. So A is a constant in the time of t, capital T, and the winner with the winner process, Z is the winner process. So okay, this is the process from the ethos lemma, derivative for the ethos lemma, and then we use them in the process. Okay, this is for that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Daniel Geloman, and my metric number 171921. Okay, I'm here going to explain one of the problem, which is problem 7 later. But before that, I explain first what is the concept that we're gonna use to solve the problem 7. Okay, the concept that we basically use for solving the problem 7 is the Black-Scholes pricing formulas. And there's two things that you guys have to know. The first is European call option on a non-dividend paying stock. And another one is European put option on non-dividend paying stock. And the difference is, just here, call option. And the other one is put option. And the formula also different. For the call option, we denote as a C here. And then for the put option, we denote as a P. And then how we get this formula, my friend will show how the derivation, how to get this formula for problems 8 later. Okay? And then of this, continue for the next one. We have the D1 and D2, like what you guys have seen here. There's a D1, D2, D1, D2 on this formula. So the D1 defined as the ln of S over K plus this one. And this formula also will be explained by my friend for solving the problem 8, which is the derivation. Okay, so we move to the problem 7. Okay, problem 7, okay, read the question first. Compute the price of a European put option on a non-dividend paying stock when the stock price is 69 ringgit, the strike price is 70 ringgit, the risk-free rate of interest is 5% per annum, the volatility is 35% per annum, and the time to maturity is 6 months. Okay, how we going to tackle this question is, you guys can see here, as stated, European put option. Okay, like the notes that I have been given, there's two things, call option and also put option. So for this kind of problem, we're gonna use the put option. Before that, before we plug in all this information here to function equation P equal to K E negative R E T. Okay, this is the put option that we will be used, and then like what I have been shown before, the D1 and also the D2. So we have to find the D1 and also D2. Okay, for the D1, okay, you guys can see here the formula is we have the S, K, R, sigma here, T, all those things. So those kind of things we get it from the problem here. Okay, first we read the question, and then we can get the information. Compute the price of a European put option, which is this one, on a non-dividend paying stock when the stock price 69 ringgit. So we denote as it's not equal to RM 69, and then the strike price is 70 ringgit. Get the strike price, and we denote as a K. Okay, and then again the risk-free rate of interest is 5% per annum. This one is R, okay, small r. So it is 5%, or we can write it in decimal 5. Then we move to the next one. The volatility is 35% per annum. Okay, for this one, we denote the volatility as a T, which is 0.35, same like the 35%. And then, not T, sorry. It's actually the sigma, sorry. And then, the information we get, and the time to maturity is 6 months. That one is the T, which is 6 months. But we have to divide it by 12 since we want to have the answer in sleep. So 0.5. Okay? And then we get those things here. We just plug in all those information here into the formula here. D1, and it leads, we get this. Then you calculate it using calculator, and then you get the answer for the D1 is 0.1666. This one for the D1. And like you guys can see here, the put option not complete enough. We have the D1 but not the D2. So we use this formula, D2. The D2 defined as the D1 minus D1. Okay, for this formula, this is actually the 2 itself. Okay, so the D1 is 1666 minus 0.35, and we have a set of 0.5. Okay, then the answer we got negative 0.0809. And yeah, we get the D2, we get the D1, and all those kind of things we can plug in into the formula for put option. So I'm going to write it right here. So the P put option, we use the formula this one. So plug in. So the P exponent 0.05, then and 0.0809 minus with the 69 and negative 0.1666. Okay, this is the formula after we plug in, and then you guys can see here there is a normal. So you guys have to solve this normal first, and then you get the answer. And finally, yeah, the answer is 6.40. So the put option is actually RM 6.40. So that's all for problem 7. The put option, European put option for this problem is RM 6.40. Thank you for kindly listening.
Very good morning. Okay, my name is Muhammad Farhan Abdulani. My number matrix is 172-418. Okay, today I will solve the problem number 8 that is given to me to solve it. So, in this question, we have given variable C, P, which is all of this is for the stochastic process. Okay, C equal to Sn d1 minus Ke power of minus R times T minus T times N power of D2. Okay. The given question is A. First, A. Find n prime x. First of all, I will explain to you about nx. Okay, nx. Okay, we have learned statistic before, right? So, nx is the normal cumulative distribution function. So, this is about statistic also. Normal cumulative distribution function, which is the formula is 1 over square root 2 pi. 2 pi minus infinite until x e power of minus t square over 2 dt. So n prime x, there's differentiate there. I know you all can do it. This is the constant, so let it go, let it be. Then e minus t square over 2, we substitute x, the t to x because of differentiate to dt, differentiate it, so it will become e minus x square over 2. Okay. What? Right. Okay. So this is n prime x. We will use this formula for all of the question B, C, and D. So for the question D, we must show that Sn prime d1 equal to Ke power of minus R T minus T n prime d2. Okay, we have find the n prime. We got the formula for C Sn d1. Okay, then remember that n prime s equal to 1 over square root 2 pi power times e power of minus x square over 2. Then d1, we use d1 because Sn prime d1 substitute into the n prime x. So, okay, we must first show this first to get the relation about d1 and d2. Okay, D1 is equal to non S over K. Roughly, I don't want to write this. Write that. For the relation D1 and D2, we can see that D1 and D2 just differentiate. The difference is in this term only. So R plus sigma square over 2 and R minus sigma square over 2. So the relation is D1 equal to D2 plus sigma square root T minus T. Okay. We can compare that when D1 just D2 plus this will get the D1. Okay, so we get the relation. We can find the N prime D1. Okay, just substitute N prime and D1. Okay, N prime D1 equal to N prime. Okay, we know that D1 equal to D2 plus sigma square root T minus T, right? So we just substitute that. T minus T equal to we use this function, this equation, 1 over square root 2 pi E minus D2 plus sigma T minus T square over 2. Okay. We got this, we solve until 1 over square D2 square over 2. Okay. We solve this step by step. We separate this E because to easier the step. 1 over square root 2 pi, let it be equal to times E power of negative D2 square over 2. We times this, but separate the E minus 2 D2 sigma square root T minus T minus sigma square T minus T over 2. Okay, we have separate both of this. Then we can substitute. See that N prime S equal to 1 over square root 2 pi E power minus X square over 2. Same like this, right? 1 over square root 2 pi E minus D2 square over 2. So just write that N prime D2. Okay, right back. We can cancel off and separate this. E minus D2 sigma minus T minus T. Then minus sigma square T minus T square. Okay. Then we can substitute N prime D2, that is E minus D2. We can see at the function there, at the equation there. So we can substitute N prime D2 K over S E power of E minus R T minus T. Okay. This is because of that function. This is just the same on same only. Thus, sorry. Thus, N prime D1 equal to N prime D2 K over S E minus R E minus T. We transfer S over there. S N prime D1 equal to K E minus R T minus T N prime D2. Because E minus R T minus T equal to N prime D2. So we have proven all of this. Proven as the given question. So this is solved for number B. I erase question A. But remember this, N prime S equal to this. We use this formula for all of the remaining questions. Okay, for the question number C. Question C. we must calculate del D1 over del S and del D2 over del S. Okay. First, we find the del D1 as the given question. D1 equal to ln S over K. This we must we must separate this. We use the formula of ln, the root of ln S over K equal to ln S minus ln K. Everyone know this, right? So D1 equal to separate this ln S minus ln K is over sigma T minus T plus R plus sigma square of 2 T minus T over sigma T minus T. So del D1 over del S equal to, just differentiate D1 respect to ds. So it will be the remaining this is a constant, so it will be deleted this also and left this only. Ln S we differentiate, got 1 over S, right? So the answer will be 1 over S sigma T minus T. This is for del D1 over ds. So we must find for del D2 over ds. Same as the del D1, just the difference is R minus D and R plus sigma square. So it's all about the same, the constant variable, all of that. So after the partial differentiate, we find that del D2 over del ds equal to 1 over S sigma square root T minus T, same as del D1. So del D1 same as del D2 ds. Okay, solve for question C. Now we proceed to question D. Yeah, here is this. Okay, for question D, we must show that DC, this one more question proof, DC over dt is equal to minus R, K, E minus R, T minus T, and D2. Minus S n prime, D1, sigma over D2, T minus T. Okay, this is question D. So we must prove DC over dt. Recall that C equal to Sn D1 minus KD, power of minus R minus T, and D2. So we must differentiate the equation, the function respect to T. When we differentiate respect to T, we not that got E in D1 and D2. So be careful on this function and D1 and D2. Be careful. So we find that del DC over dt equal to Sn prime D1 del D1 over del D2 because of D1 got D. Sorry, minus R minus 1 K E minus R T minus T. We use product rule to differentiate this because get T and get N prime D1. So we get this T minus T and D2 plus K E minus R T minus T N prime D2 del D2 over del T. Okay, we get this function. So after we use the from question B just now, the N prime we just substitute minus KRT D1 as N prime. Okay, from the question B just now we can solve this to short with the way. So it will be as N prime D1 then D1 over del T minus R K KE minus R T minus T and D2 minus S N prime D1 then D2 over dt. Solve this until we factorize until we get minus R KE minus R T minus T and D2 plus S N prime D1 then D1. This just use the simple algebra, just factorize it then D2 over then D. Okay, from the question B also we have proved that the relation between D1 and D2 is D1 equal to D2 D2 plus sigma T minus T. So we got this del D1 over dt minus del D2 over dt. Just use this D1 minus D2 equal to sigma square root T minus T. Differentiate respect to T and then we get del D1 over del T minus del D2 over del T equal to sigma 2 square root T minus T. Okay, we use this, substitute into this. Then we got that del C over del T equal to negative R KE minus R T minus T and D2 minus S and prime D1 sigma 2 square root T minus T. Proven as the equation above. Then for the final equation is D. So I did the equation C. The equation E shows that del C over del S equal to N D1. This is just a simple proof. So we know that C equal to Sn D1. Use this formula. We just differentiate C, partial differentiate C respect to S. Del C over del S equal to N D1 respect to S plus Sn prime D1 del D1 over del S minus K E minus R T minus T N prime D2 del D2 over del S. Okay, from question B also we use the equation before this, the n prime one and the C over del S we can solve. N D1 plus S n prime D1 then D1 over del S minus S n prime D1 then D2 over del S. Okay, we know that del D1 over del S same as del D2 over del S, which is equal to 1 over S 1 over S sigma times T minus T square root. So we can solve S over del S equal to N D1 plus N prime D1 over sigma T minus T minus N prime D1 over sigma T minus T. This is the same, so we can cancel off. Go to N D1. So we have proved that then C over del S equal to N D1. Okay, that's all from me for all of the questions. Thank you.